So yeah, thanks for the introduction. My name is Josh Watzman. I'm a software engineer at Facebook. Have been for the last 4 years. And for the last 2 or 3 of that, I've been working on Hack, which is Facebook's typed dialect of PHP. And I'm going to be talking this morning about how, over the course of 2013, Facebook converted from PHP to Hack, both the technical aspects of how we actually did that conversion, and more the social aspects of how we convinced a large engineering organization that we should do something like this. So a little bit of background on Hack. It is, as I said, a dialect of PHP developed at Facebook. It is statically typed, meaning that we have a type checker, which is separate from the runtime, that enforces the static type system of the language. But more than that, it is gradually statically typed. You can omit type annotations in anywhere that are syntactically valid, you can omit them. And if you do, the type checker will just assume that you know what you're doing and allow the code to pass. This gives it full interoperability with PHP because the type checker just sees PHP as completely untyped Hack in most cases. So the goal here was to increase developer productivity by keeping our existing PHP codebase, our existing knowledge and value built up there, but adding in a static type system to catch bugs and help our engineers move even faster. It runs Facebook.com, tens of millions of lines of code in our web front end, and it has since the end of 2013. I'm going to be talking today primarily about Hack's static type system, but it has many other cool features in the language, which came later, after the time I'm going to be talking about. And you can get the full details of the other features in the language at hacklang.org, as well as there are links there to the open source implementation in type checker. Everything I'm going to be talking about today, the source code that we use internally at Facebook, is available all on GitHub, and there's a link at hacklang.org if you want to check it out. So let me give you just a quick background and a quick example of what some PHP looks like, and what some Hack looks like. So on the left here's a fairly standard PHP function. If you're not familiar with PHP, PHP files start with !PHP, and the rest of the syntax looks like your general algol or C derived code. I defined a function here called increment that takes an element x, returns x plus 1, and then a function f, which calls increment, and then echoes out the value. If you were to call f, you'd print 43 to the console, as you'd expect. So let's look at what the corresponding Hack code looks like. It's over here on the right. The most important change here is actually at the top, that we've changed the opening tag from PHP to HH to signify that this is now a Hack file. And then we've added here a few type annotations. This increment function is now explicitly typed as taking an int for an input and returning an int as an output. That was clearly the intent on the left, and we've actually codified it in a way that can be statically verified on the right. Return x plus 1. This local here, the x plus 1, the type of that is inferred, as is the type of y here. We know since increment returns an int, y is an integer. You're allowed to echo integers. And f doesn't return a value, so in the C parlance, it returns void. It's worth noting that the type annotations that I've written on the right here are just to illustrate differences between the two. It would be perfectly legal Hack for me to omit any or all of these type annotations. And the type checker would just assume you know what you're doing whenever you hit one of those missing annotations. But it wouldn't be a very interesting slide if it were the same code on both sides. So as you can see from that example, Hack looks a lot like PHP. And so it was built such that we could mechanically convert from PHP into Hack, starting with a manual conversion, snowballing that, and then going into a full mechanical conversion. And here's what that looked like at Facebook over the course of calendar year 2013. We started collecting data somewhere around February when we had something like 10% of the files in Hack. Sorry, this graph is percent of files in Facebook's front end in 2013 that had HH at the top versus those that had PHP at the top. So we had about 10% of Hack files starting here when we were collecting data, going up through this middle part of the graph with a sort of manual snowballing conversion. And then over here, sometime in August, we did a series of mechanical conversions, which is where you get these big step discontinuities. And we became 95% Hack by the end of the year. So the conversion effort that we did took place in 3 major stages, which are going to be the 3 major parts of my talk this morning. There was the first stage, which is what I call the live or die phase. whenever we were getting the type checker up and running, we were demonstrating that what we were doing could even be done at all, that a typed PHP was a thing that was possible to build. Then in the momentum stage, we sort of had a prototype, or something a little better than a prototype, but it wasn't quite finished. We had to convince the engineering organization to start converting some of their code, build momentum around the project until we could get to the victory phase, where we had convinced the engineering organization that this was great, we're going to do this, and then we did the mechanical conversion. I'll take questions at the end. So here's where those phases lie on this conversion graph. The deliver die phase is actually off to the left of this. We were so focused on trying to get the type checker up and running, we weren't collecting data yet on how many files were in what mode. Once we did start collecting data, then we have here the momentum phase. The general snowballing conversion. People are sort of picking up Hack, looking at it, trying it out. We're convincing small teams to convert some of their code. And then we get over here to the victory phase, where the engineering organization as a whole was behind a big mechanical conversion, which we just went and did. And so let me get to the first phase of this, which is off to the left of this graph, the deliver die phase. So first, some background on the engineering culture at Facebook. The most important thing is that Facebook doesn't have any sort of top-down mandates on the way most anything should work, but most importantly, on the way major technology decisions should work. The way that you get something like Hack deployed at Facebook is you convince the engineers that it's a good idea. We have this saying, code wins arguments. It's not about convincing specific managers or execs that they should do this, and they don't decree that anything should or should not happen. You convince the other engineers to pick it up, and if people think it's a good idea, they'll start picking it up, and it'll start gaining momentum, and more people will hear about it, and then they'll want to use it too, and that's how technology gets adopted. So you build something good, and then convince engineers that it is good and to use it. So in that environment, the genesis of the project started in late 2012 or early 2013 with these two hotshots out of security engineering. This is Julian and Alok. The original idea that they had was that PHP is dynamically typed, and that can lead to certain classes of bugs. And if you were to, for example, want to write an SSL crypto library, and that's the sort of thing, since they were in security engineering, that's what they wanted to do. If you were going to write an SSL crypto library, it's really important that you get that sort of thing right. And so you can do that in a dynamic language with a bunch of manual testing, a bunch of code review, a bunch of automatic testing. But certain classes of bugs could be completely ruled out if you have a really strictly typed language. For example, like in a statically typed language like Haskell or OCaml, there are just certain bugs that are ruled out by the type system. And so if we can have a fully typed variant of PHP, well, we'll still need code review, we'll still need manual testing and automatic testing, but it'll definitely cut down on the burden, and we can move a lot faster and a lot more confidently without spending a bunch of time verifying that we're not having like crypto bugs somewhere. And so the original idea was to rewrite key parts of the site in this 100% fully typed version of PHP. That code would be fully typed, all of the code that it called, and all of the code that that called, et cetera, would be fully, completely statically typed. And so you could have a lot of these guarantees around the code. However, there were pretty immediate changes in this approach. As soon as they built the prototype, they realized that that wasn't really going to be feasible. When you're in an environment like Facebook, we had tens of millions of lines of code, and you want to be able to leverage a lot of the existing code that we have. Even if you're writing some quasi-leaf node, like an SSL crypto library, it lies towards the bottom of the stack. It turns out nothing is ever really completely a leaf node like that. The SSL crypto library, for example, you could make it statically typed, but now somewhere in the middle of it, it's going to want to do some logging. You do that sometimes. Now the logging library has to be completely statically typed. But the logging library, it probably logs to a few different places. It might log to disk, it might log to some log aggregation service, it might log into a database. Now each of those have to be completely statically typed because it had this transitive property. And so almost immediately, this wasn't going to fly. The language was way too restrictive. You'd end up needing to rewrite half the site all at once, which wasn't a feasible thing for us to do. And so they pretty quickly introduced the notion of gradual typing that I talked about at the beginning, that you can rewrite the core parts that you want and get the static guarantees over those, but it can still call into other bits of code. It doesn't have to be transitive in this way. And so you can get the guarantees about the code that you're writing, and if you're willing to assume that a lot of the libraries you're calling work as intended, and can guarantee that in other ways, then you can continue working, and the language sort of hangs together a lot better. And importantly, you can convert your code gradually. And so the scope at this point pretty quickly expanded from restricted PHP to typed PHP. As soon as you introduce this notion of like holes in the type system, the way you type check it becomes a lot more interesting. And they realized this language would be more generally useful than just security engineering. And so the way you need to build out and scale the type checker becomes a lot more interesting problem. And so they did try and scale out the language. And in order to make it generally useful, you've got to go and make sure that it's going to be able to type a lot of the idioms that you have in your existing code. And so here's an example of the sort of thing that we did, which was go around, look at existing code, try and type that code, and see where the type checker fell down. So here's an example of a fairly common idiom you'll see in PHP and in Java as well, and some other languages, and you see a lot at Facebook. This is legal PHP on the left. PHP doesn't have a static type system, but it does have object type annotations on function parameters, which are validated dynamically at runtime. Effectively, when this function is called at runtime, it'll check and make sure that this $x is actually an instance of ifoo, and throw an error if not. And so you can have code that looks like this. You have an ifoo coming in, and you want to call the foo method on the ifoo interface. And they say, oh, if this ifoo, this $x, if that's also an ibar, I want to call the bar method. And bar method is defined on ibar, but it's not defined on ifoo. And so when we went and took this PHP and converted it to an HH, a naive version of the type checker would balk at this code. It would say, you've got an ifoo, and down here you're trying to call bar on it, and bar isn't defined on ifoo. And so this is one of the first things we ran into. It's like, OK, the type checker needs to be sensitive to language constructs like this instance of. And it needs to know that if this instance of passes, the only way you can get inside this if block is if the instance of were to pass at runtime. And so you're allowed to assume statically that inside the true branch of the if block, this is now an ibar, and you can call the bar method on it. Again, this isn't a particularly novel or interesting feature of the type checker, but it's just indicative of the sort of things that we had to do, that we were going through, looking at existing code, trying to convert it over to hack, and seeing what features the type checker needed. We were doing, the way I sort of want to summarize the live or die phase is anticipating and removing friction. We were making sure that as soon as anybody were to start using this system, it would go really smoothly, that a lot of the kinks had been worked out ahead of time. Another important way that we anticipated and removed friction was via performance improvements to the type checker. At some point after this, we had the type checker being used by maybe half a dozen ultra-early bleeding-edge users with maybe 24 files written in hack. Tiny, tiny usage at Facebook at the time. But we knew that ultimately our goal was going to be to convert more and more and more code. And so we did a back-of-the-envelope calculation to see if we converted all of Facebook's code right now, how long would it take to type check? And the answer was something like 6 hours. That's an impressively long time for anything like this. We wanted it to fit into our engineers' workflows. The goal was that we could be type checking as they were working. At 6 hours, it has to be an offline job, and that wasn't where we wanted to go. And so we decided we should parallelize the type checker, and we should do it now before it became a problem. We wanted to anticipate and remove the friction of performance problems. Parallelization is difficult. You run into all sorts of concurrency issues. And so I think it's really fun the way we did this. We kept the single-threaded version around, and its result was canonical when we reported it to users. But we added in the multi-threaded version behind the scenes, and we just emailed ourselves whenever the two results didn't match. And as soon as we got to a place where we were confident that the results were the same, we flipped it over such that the multi-threaded version was now canonical. Nobody noticed, which I think means it was pretty successful. So parallelizing got our type checking time down, or our estimate of where it would be if we type checked all of Facebook's code. Parallelized was about 50 seconds. But we decided that even that was too slow. Facebook's engineers are used to one of the great things about PHP. For as much flack as people like to give the language, there are a lot of nice things about PHP. And one of the major ones is that it doesn't have a compilation cycle or a type checking cycle. You can write some code, save your file in your editor, and then immediately tab over to your browser and press refresh, and you can see the changes that you've made happen immediately. Even, we realized even a 50-second latency there, which is nothing for anybody that works in C++, for example. Even a 50-second latency was going to be too much for our workflow. But we also realized that we have tens of millions of lines of code. We don't need to type check all of them all the time. We can have a server running in the background that maintains state, and we can update the state incrementally, which is what we did. We built that out. We have incremental mode now, or we had incremental mode back then pretty early. And so this dropped our average latency for type checking from 50 seconds to type check everything to about 100 milliseconds, since if you're changing about 5 lines of code, that's not really that much work to do. And we accepted that 100 milliseconds is a pretty good latency for type checking. Again, we were anticipating and removing friction of the performance problems that we knew would block adoption of this system if anybody were to run into these problems. And we were pretty quickly vindicated that what we had done was the right approach. One of our very early users, one of these like dozen or half dozen people that were using it from the beginning, came to us one day and said, the release of the type checker you just did, you introduced this like horrific performance regression so bad that as much as I love types, I had to go back to using PHP. I unconverted all of my code. Please fix the regression, and then I'll go back to using hack and reconvert it. And so we're like, oh crap, what did we do? What happened? We like ran over to his desk and had him show us, and he's like, yeah, here's your terrible regression. Look at how slow type checking is. And we like, it's taking half a second. And he's like, yes, that's way too slow to fit into my workflow. Like, I can't deal with this. So we were vindicated that, yes, half a second even was way too slow. The performance work that we'd done was important. Thankfully, in this case, it was a stupid bug we could fix in 10 minutes and redeploy. But we correctly anticipated and removed the friction of the performance problems to get it out of the way before we got any sort of wide usage or even attempted to get any sort of wide usage of the system, such that it worked smoothly for people from day one. One place where we didn't anticipate and remove friction and that it caused us some problems was on some objections and general pushback we got from our engineering organization. Again, Facebook does not have a very top-down culture, and so we needed to convince the engineers that what we were doing was a good idea. We have a very open culture, so people were hearing about this, even though there weren't very many users. The knowledge sort of spread through the grapevine of the system that we were building. And so we got a lot of pushback that maybe this wasn't such a good idea for us to be doing and for Facebook to be investing in. People would say things like, well, maybe it's a good idea, but these two hotshots out of security engineering, they're not real experts on this. We need a real expert to build this out. Or what happens if you fail? What do we do if there's a half-assed language left in our code base? Now we're in a really bad spot if we don't have a rollback plan. What is your rollback plan? These are the sort of things that people would come to us. Lots of people would come to us with concerns. And so, in hindsight, some of this is kind of silly. We need a real expert. Well, we know sitting here in 2015 that we pulled it off. But back then, none of these things are unreasonable objections. Imagine if someone came to you and said, like, OK, I got this great idea. I'm going to rebuild the Linux kernel, but better. You'd probably sort of roll your eyes and say a lot of these things back at them. It's like, what are you doing? You're not an expert. You need someone more qualified than you to rewrite the Linux kernel. So how do we deal with some of this pushback? We basically said, let us build trust and we can execute on this. We're not going to get in your way until we have something that's good and we've demonstrated that it's good and we can convince you with a real system that works that we are able to pull this off, and we'll stay out of your way until then. And furthermore, if we fail, the design allows mechanical removal from the code base. All we were doing at this point was adding types in more and more places and building a separate type checker to verify those. So if the system fails, all you do is delete all the code for the type checker and then run a not even that complicated sed script across all of the code base to delete all of the types, and you're back to where you were. In general, we went around just reassured people we're not going to cause problems, we're going to provide positive value, we are able to do this, and if we aren't, we have a plan and it's not going to hurt you. Importantly, we divided the people that we were talking to up into 3 camps with this stoplight system. We had the red light people, the yellow light people, and the green light people. The green light people were totally on board. Don't waste your time with them, they're convinced. The red light people, you're never going to convince. They think that PHP is the best thing ever, that types are from the devil, and you're never going to convince those people either. And so we spent our time on the yellow light people who maybe didn't think this was such a great idea, but were kind of on the fence, and we thought we could convince, or at least convince to not argue against the project and let us build up the trust and the value that I've demonstrated here. So again, in the live or die phase, the way that we had success here was to anticipate and remove friction, getting the performance problems out of the way early, making sure the type checker could understand code people were actually writing. And what we should have done is got ahead of the messaging a little bit on how we were selling this and how people were perceiving it, such that we didn't get this big pushback from an engineering organization. And we didn't do that, and that cost us some time in the end. So the second phase, momentum. Here on my graph earlier of the conversion, starting from, well, maybe a little off to the left of this before we started collecting data, but not too much. Getting from that 1% and 2% up to the sort of, I think this is about 45% in the middle here, building up the momentum in our engineering organization and convincing people that this was a good idea. Beyond just, don't kill the project, it's actually a good idea. One of the first things we did was, if you remember, it was started by these two hot shots out of security engineering, security infra. And so the team at the time was still under the security infra organization. And we realized that if we're going to do a wide-scale conversion, one of the first things we need to do to build momentum is to not scare people that the security team is making core language changes. And so it was a purely clerical thing. We reorged ourselves under the compiler team, but we knew it would make people feel better. And so the organizational structure didn't matter too much to us. We're still doing the same work, and so let's just move over here, or reconnect the wires in the org chart, and it made people feel better. We could leverage the compiler's team's position. So after having done that, one of the major ways we started getting the ball rolling was via actually a couple of the yellow light people I talked about a minute ago. There were two very well-respected engineers that we did end up convincing. That we did end up convincing that hack was a good idea. And so again, they were well-respected engineers, so people listened to their opinions and sort of, I don't want to say quite followed them, but at least take into account what they were saying on a wide basis. So when they went to their teams that they were the tech leads for, and just sort of gave a wink, wink, nod, nod to their teams, there's this hack thing, I think it's kind of cool, if you're interested in types, you should check it out. That got us our first, half dozen, 2 dozen early users. Just enough usage to trickle in from people that were really gung-ho, that we could solve some of these early problems, that we could get real-world usage, but without being too much when the system wasn't quite ready for it. So that worked out really, really well for us, that we got this small trickle of usage from the wink, wink, nod, nod from these originally yellow light engineers that we had convinced. That was a lot of fun. One of the very early adopters at this stage was a guy named Gabe, and he ended up being pivotal to our strategy here. Gabe was working on some of our front-end data fetching abstractions. The abstraction that he was working on had a lot of guarantees that it wanted to make about how it checked privacy, how it dealt with data fetching errors, and the intersection of a lot of these complicated things. And so it was very important that when he wrote an API for this data fetching, that people used the API correctly. He had a lot of, again, automated testing and manual testing and code review that was going on in order to ensure that it was correct. But he realized that using a proper static type system could save everybody a lot of time by statically guaranteeing a lot of the things that he wanted to guarantee about his API. And so when he heard about hack, he was like, great, this will save everyone a lot of time if I use this in my core abstraction. But the system wasn't really ready to express the sort of things that he wanted to express in his data fetching abstraction. And so he ended up coming on board to join the team in order to flesh out hack both for his project and for others that were wanting to do similar sort of things. And so once Gabe joined the team, he and Julian and some of the others and I were fleshing out the type system, getting it ready to have our first major conversion of a major piece of code. We'd fleshed it out more and more. And having Gabe on board led to that first major conversion, which was the ads team. Gabe was good friends with the tech lead on the ads team, and basically sold to this tech lead the same thing that Gabe was sold on in the first place. Ads is dealing with money. It's very important that everything we ever do in ads is correct. We have lots of process in place in order to make sure that's the case. lots of code review, manual testing, automatic testing. And again, those things are still going to be necessary with a static type system, of course, but it can reduce the burden of a lot of that if you can statically guarantee a lot of things about your code. And so the ads tech lead was pretty easily sold that it would save his team a good deal of time to convert over to Hack and to get the static type system there in order to better ensure that the ads code was always correct as it had to be. And so Gabe went and sat with his tech lead as they converted a bunch of the ads code and gave them immediate debugging support, which was very important here. As soon as an issue was encountered by Gabe or the tech lead or the ads team, Gabe would be there to debug it. And it made them feel really good that the system was working for them, that all of their issues were getting solved immediately. The issues, of course, were not specific to ads. It was about the system in general. And so we just invested a lot of effort to make sure this first big conversion, went really well. And it did. The ads team was pretty happy with the productivity gains from the type system and with the attention that we were spending on them in order to make sure that it went well. The major thing we were doing here was using one entry point to leverage the next. We were using our original wink, wink, nod, nod from those yellow light, now green light respected engineers to get our first early users. One of our first early users was Gabe. Gabe got us in with the ads team, and we were able to leverage all of those to get the ads converted. Once all of the ads code was converted, we were able to leverage that to get the next major conversion, which was the platform team. This was sort of a natural next step for us, again, because Gabe used to work on platform, and he knew a lot of the people there, was familiar with a lot of the code. There wasn't any sort of gung-ho tech lead, though, on platform like there was with ads. But one of the great things about Facebook's open engineering culture is we didn't really need one. Gabe went into the usual communication channels for the platform team and said, I'm going to go convert your code. The ads code has been successful. We've fleshed out a lot of the issues there. I'm going to go do this in a couple of weekends. Please tell me why I shouldn't do this. What am I going to do that's going to hurt you? Let me solve those problems first. And so he made sure that any issues were solved beforehand. I don't think there was too many problems here. And just went and converted their code over the course of one of the weekends. And it went pretty smoothly, which is great that he was able to do this. But he just converted their code, and it went well, and life went on from there. It's important, I want to make explicit here something that I've been implicitly relying on and alluding to, that engineers, and humans in general for that matter, are amazingly apathetic people. The entry points we're using, when I say use one entry point to leverage the next, those entry points are not every single engineer at Facebook. It's certain key points that we needed in order to leverage the conversion and make it work. But most engineers just didn't care what was going on. As long as we didn't get in their way, then it's like, whatever this technology change is going on behind the scenes, you're not in my way, I'm still doing the work like I was doing before. They didn't care. This gave us time to do some of these conversions, to fix bugs and flesh out issues, such that when we did start getting in people's way, the value that we were providing was all positive value. We were catching bugs. We were able to make our autocomplete smarter by the additional type information. We were able to provide value from the first time most engineers encountered the system because we were able to do it behind the scenes when they just didn't care, and until we could get to the point where we provided a good positive value. And so this was really important for us in order to get this conversion working. The flip side of this is, though, if you do get in people's way and you are providing negative value, they're going to want to kill the project pretty quickly. So don't do that. And we were lucky that we were able we very carefully engineered the conversion such that we could stay behind the scenes outside of ads and outside of platform. We were still kind of staying behind the scenes while we made those conversions successful, such that we were able to provide positive value from day one. The ads conversion and the platform conversion having gone well, another way that we continued snowballing our success was via the Hack internal support group. Facebook, of course, uses Facebook internally. We use Facebook groups. And so very, very early on, we created a Facebook group for people to discuss the Hack language and either problems or misunderstandings that they were having. So in the early days, it was the Hack core team in this group answering questions from our early adopters when they didn't understand a type error. And a lot of it was like bug reports and finding and fixing bugs. But as we converted more and more code, we had the core Hack team that had helped those first early adopters. But then it became those early adopters helped the next round, and the next round helped the next round, and so on and so on and so on. And the group actually snowballed really well and was a major way that helped the conversion snowball by just having engineers help other engineers. And at this point, the Hack Core team actually doesn't need to do a whole lot in this group anymore and hasn't for quite a while because we have the competency built up in our engineering organization for engineers to help each other as that built out. And I don't know if you can read this in the back, but it's worth looking at the member count of this group nowadays. When I took this screenshot a few weeks ago, it was well over 1,000 members in this group, which is a pretty significant fraction of Facebook's engineering. And so this group is actually a really great way for us to help engineers let other engineers know about the system and solve common problems with it, and just generally build understanding about what was going on, even things that weren't bugs, just people aren't familiar with type systems, and help them understand what's going on. So after all of this, there are a couple of key events that happened that sort of blew us away, that let us know that we had been successful. The first one was when a tech lead on the compiler team, or a former tech lead on the compiler team, got up at an all-hands, talked about the compiler and where it had been, and presented Hack just as a part of that presentation as a done deal. Something that, like, of course, this has happened, this is done, the conversion's going on, like, it's a done deal, it's over with. Which was pretty surprising to us that it was being perceived that way, but really cool for the team to say, like, I guess the momentum that we've been building, the conversions we've been doing, really have been having an effect on our engineering organization. My favorite, though, was an engineer on the privacy team. She had just been a tech lead over a major refactor of a bunch of our privacy code to make it a lot faster, a lot easier to change, and give it a lot of really nice properties about our privacy code. So she got up and gave a tech talk about, like, how we improved everything in privacy all at once. And somewhere halfway through the presentation, she made an offhand comment saying, of course, this is all written in Hack. Didn't even give it a second thought, didn't think it was worth a second thought, and just moved on. And so again, we were like, wow, people are perceiving Hack as like an of course sort of thing. We really have won the hearts and minds of most of our engineering organization at this point. And this is when we started considering, like, maybe now is the right time to do a mechanical conversion. So again, to build momentum, the core summary of the way we did this was using one entry point to leverage the next. Use our early adopters to get Gabe on the team. Use him to convert the ads code. Use the success of the ads conversion to convert the platform code. Use the users that we've gotten gung-ho about the system from those successful conversions to get in the support group, to help the next group, and to get the next people on board, et cetera, et cetera, et cetera. Finally, victory. The big mechanical conversion, the step discontinuities here. We'd won the hearts and minds. We'd had this privacy engineer and this tech lead come and tell us, or not come and tell us, but just like tell everyone else, like, of course, Hack is great. We should do a big mechanical conversion now. So what needs to happen for the mechanical conversion to happen? Well, the first thing is that we sort of hit a brick wall immediately with memory usage. This was actually really embarrassing. We had to be told by our continuous integration people, who were, of course, running type checking all the time in order to make sure that trunk didn't break. They told us that we were running the CI systems out of memory regularly. And we hadn't been tracking memory usage at all. And when we went and looked at how much RAM we would need in order to type check all of Facebook's front-end code if we were to convert it all right now, the answer was well over 100 gigabytes of RAM. Which we knew was not really acceptable, was sort of an order of magnitude off of being acceptable. So it's like, crap, we can't do the mechanical conversion now. We're going to run every system in the fleet out of memory. So we had to go and rewrite the storage layer before we could even start thinking about the conversion, even though we knew we wanted to do it. It was pretty embarrassing. It stopped us in our tracks. We should have been tracking memory usage, and we weren't. Something that we were tracking, thankfully, was trunk being broken and trunk breaks. We sort of had been getting qualitative complaints of trunk breaks for a while. We actually had to decide what a trunk break meant. When you have this type system enforced by a separate binary, there's a couple different meanings you can assign to trunk being broken qualitatively. Does it mean people are actually not able to do work, or does it just mean there's a type error in trunk and it's kind of annoying them and getting in their way? We decided that it meant there's a type error in trunk, so we should have a metric that tracks that. And so we tracked percentage of the week that there is a single type error checked into trunk. Now that we had a metric, we can drive this metric down to 0, no trunk breaks. How do you do that? You watch code being committed, you watch code being reviewed, and you have Gabe go and read all of the code and all of the problems and help people understand what's going on and fix it. Ideally, we would have actually instituted a commit hook such that you can't commit type errors at all. But for technical reasons I won't go into, we couldn't do that. And so we had to do it this way. But we successfully drove the number of trunk breaks down to 0, or nearly 0. What we were basically doing here was picking the right metrics and then optimizing them. This is actually fairly obvious advice for anybody who's ever worked in product or done a product launch. Of course, in order to increase likes on Facebook, you track likes and then make likes go up. But the major thing we did here was treat our type checker deployment, our language and technology change, as a product launch, which it really was, to track the right metrics and then optimize them in that way. And then we decided the metric we wanted to track and optimize was percentage of files in hack, and then went after that. This was actually probably the easiest part of the whole thing. We wrote a simple tool that changed the PHP to HH at the top. If that didn't cause type errors, it committed the change. And so Gabe just spent a couple of weekends just running this tool across our code base and landing the changes. Again, one of the great things about Facebook is that you can just go and do this over a weekend. He worked with source control and with release engineering to make sure there were no serious problems. But basically, he just did it more and more frequently as he gained confidence. And so you get these large discontinuities here. And we hit 95% conversion by the end of 2013. So in the spirit of pick the right metrics and optimize them, when do you declare victory became an interesting question at this point. What's the right metric? When do we pop the champagne? And so we went back and looked at what our goal was for the year, which was Facebook as a hack company. And we decided that, OK, well, the system's gradually typed. So even though we have 95% conversion, we don't have 95% coverage, but there's hack at the top of every file. You can put types anywhere. We are a hack company. There are type checkers running over everything. We can increase typed coverage later. We can open source later. We can add all the language features we want to add later. We are a hack company. The metric we want has hit the place we want it to be. And so at the end of 2013, we had a big party and popped the champagne. All the other stuff would come later. So to summarize, the keys to our success, how we pulled off this conversion. First, in the live or die phase, we anticipated and removed friction. We made sure that when people used the system, it worked well from day one, that it was fast, that it was stable, that it typed the things they want to type. To build momentum, we used one entry point to leverage the next, to help get more people on board, to build success, and use that success to build more success. And finally, in the victory phase, we treated it as a product launch. We picked the right metrics, and then we optimized them and made sure this was successful as a product launch. The anecdotes that I've been telling today are, of course, specific to the way engineering works at Facebook. But I believe this general approach and the general ideas here are, well, general and applicable very widely. For example, when we released Hack in the open source world, we wanted to increase adoption similarly to how we did at Facebook. And so one of the major things we did was to anticipate and remove friction. We made the install process dramatically easier than it had been at Facebook in order to ensure that people could pick up the system really easily from day one. And generally have been following these trends and ideas as we have had Facebook in the open source world. Thanks, that's all I have for the presentation. I believe we have a few minutes for questions, so happy to take a few questions.